Let's take a look at problem 9.13 from your textbook. You need to complete the following reactions and you need to show the configuration of the product if needed. Alright, so I like to view this reaction in the line formula. So if that is the case with you, you can go ahead and just do the line formula. You have 1, 2, 3 carbons here. 1, 2, and 3, and the halogen. And this is your nucleophile. And the ethanol is acting as your solvent. And the book is telling you that these reactions are SN2 reactions. So you don't have to think SN1 or SN2. And you need to keep in mind that even if the reaction is SN1, the outcome, the product will look the same as if it is a SN2 reaction. The outcome is the same regardless if it's SN1 or SN2, but the mechanism will not be the same. And you have to pay special attention in the case when you can do the rearrangement, because in that case, then the SN2 and the SN1 will not look the same due to the rearrangement for the major predicted product. All right, so in this case, all of these reactions are SN2. So what we have to do, we need to identify the leaving group. In this case, is the halogen. When you are using a haloalkane, the leaving group will be your halogen. And this ethoxide, this nucleophile, will be replacing this leaving group. So 1, 2, and 3 carbons, right? This carbon here is this carbon here. And instead of the halogen, because now that will be your leaving group, you will have this nucleophile. You will attach it by the oxygen. So put oxygen, and let's see, what else do I have attached to the oxygen? Well, you have 2 carbons, 1 and 2. So 1 and 2. And that is the product of the reaction. Let's take a look at the next question, the next reaction. So you have the CH3I, this is your leaving group, this halogen, and that will be replaced by the nitrogen right here. And whatever is attached to the nitrogen, this is your nucleophile. So you will have the CH3, and now you will have nitrogen, but that nitrogen is attached to 3 methyl groups, so CH3, CH3, and another CH3. Because you have 4 bonds around the nitrogen, the formal charge on that nitrogen will be +1. To cancel out the balance, you can show the leaving group right next to that positive charge. Let's take a look at the next reaction. Now you have this leaving group, CN with a negative charge, that is your nucleophile. It's a nucleophilic substitution, so what you will do is just to substitute the halogen with the nucleophile, and that's it. So CH2, this CH2 is this CH2 here. And instead of the halogen, you will put the CN. And the Br is your leaving group. Okay, next question. We have the shared conformation. This is your haloalkane. The halogen is your leaving group. And this is your nucleophile. Okay, keep in mind, this is a nucleophilic substitution reaction. So what you will do is substitute the halogen with your nucleophile. And the configuration, the stereochemistry is shown here. So this Cl is going down. And keep in mind for SN2 reaction, and this is an example of the SN2 reaction, you will have the inversion of configuration. So once you put the nucleophile, then you will have the opposite orientation. The nucleophile will be going up. So now instead of down, we have it up. The nucleophile is, this is your nucleophile, so S and then CH3, and we will have the chloride ion as the leaving group.